Hello, this is Phil Thomas from New Era Systems. Today I'm looking at an Uplink Power Controller. This is the sort of thing that would be resident in any teleport because it's a well-known fact that the weather conditions can cause attenuation to the signal that's going from the teleport to the satellite. And for a satellite link, in other words, between the customer on one side and the customer on the other side, to remain constant, the power between those 2 points must be constant. And this is what the Uplink Power Controller does. It takes the output from a modem. Let's say that modem is connected to a customer in Nigeria. Depending on the size of that carrier, it may be tiny, like a 64K, it may be a 5 meg carrier, but that carrier is going to require a certain amount of power. Obviously, the smaller carrier will require less power and the larger carrier more power. And if you have 5 different links going over a satellite, the UPC will monitor each one of those links, and it will detect when the weather conditions have changed and it needs to output more power. Now, it does this by using receivers. That carrier to Nigeria could be looped back, and the teleport can be looking at its own loopback signal through a down converter and the received side coming to a modem. Or you can use something more sophisticated like a beacon receiver. Most teleports use beacon receivers. But with this particular device you can attach two. It will compare the input from the beacon receiver with the loopback signal coming from a down converter. And it will balance the two so that there is a fail-safe. Now let's look at it more closely. First thing we notice, we have dual power supplies. So even if one power supply fails, the unit should continue to operate. This is part of a complete redundancy package, and this unit has to work well, otherwise everything else in the chain could fail as well. Now, we talk about attenuators. Over here we have slots for up to 10 different attenuators. There could be 10 different carriers being monitored. And you have an input and you have an output. I may have got that upside down, but anyway. The idea is this is connected directly to the modem or modulator that's providing the output on a particular carrier. Again, let's go back to Lagos, Nigeria. One modem is supplying that perhaps 256K output to Lagos. If it detects on the input side that there is a problem, it will automatically increase the power by a few dB to compensate. Everything has been set up in advance, so you know where you should be on that particular carrier. Now, let's suppose that we're going to have another carrier going up into perhaps Ghana. We will install another one of these over there, and that will connect to the output side of the modem. Don't forget there's going to be a different power level for Ghana because it may be a different carrier size. And so that second channel would be monitoring Ghana. This is where we have the two inputs. The input can be either from a beacon receiver, or it can be the downlink signal coming back from the carrier, one of the carriers that you're transmitting. So in other words, it goes up to the satellite turns it around, and you're looking at that same signal on the receive side of this unit. At the moment we're looking at the status screen, and it gives the status of all voltages, plus 20, plus 5, all the way down. And this particular unit shows a pass everywhere. There is only one attenuator, and that's shown at the top. It has tested it, and it found it to be passing. Several different screens. Now, when this particular one started up, momentarily it showed a neg 15 volt fault, and then a plus 5 volt fault. This is often because the two power supplies, PSA A and B, do not start up simultaneously, and you can see a fault. What I can do, of course, is to clear the log. Press enter to clear the log. And if we came back to this in a few minutes, we would see if there were any more faults. History, level, status, setup. Just look at setup. In this particular case, the date is wrong, October 25th. So what I'm going to do, I'm just going to change that. Date and time. And I use this wheel, so I'm going to change it through to February, press for the next, and today I believe is the 5th or the 6th, it doesn't matter, we're just demonstrating. February the 6th, and the date is 2017. And now we can move ahead and put in the time instead. I'm just going to press enter to set it. So it's set at just after midnight. Okay, let's go back to the main setup screen now. And now this is where we set up the attenuation levels, all kinds of different things for the receivers, because don't forget I said that receiver A and receiver B will not be the same. And this is where the compensation is set up. This would be the setup for a channel. In this particular case, there is only one attenuator channel, and it's been set up to a 6 dB. Now there is a great deal more to be discussed on the setup. It's very technical. It's way beyond my capability. All I can do safely is look at the status screen and see that everything seems to be working normally, and then I can declare this unit tested to a point and working and ready for shipment.